Okay, as I started to talk about in the last video, if we have y squared, well, let's start off with y cubed. Y cubed is y times y times y. There's 3 copies of the y. Y squared is y times y. That's 2 copies of the y. Y to the 1 is just y. And all of these I could say they're equal to that times y. We're just getting rid of a copy of y. Y to the 0 we saw in the last video is just equal to 1. Now, one way to look at these is each time we go a step in this direction, each time we go a step up, you can see I'm multiplying by y. I'm adding a factor. I'm multiplying by y. I'm gaining a factor of y each time. Another way of looking at that is if each time you go down, you're dividing by y. Here I'm losing a factor of y, which is the same as dividing by y. That divided by y is just y. Y divided by y is 1. That fits into the pattern. If we want to go one more step, well, we're dividing by y one additional time. We end up with 1 over y. If we want to continue going further here, we end up with, this thing divided by y is going to be 1 over y squared, and so on. So it turns out, in general, if we have a negative exponent like this, we can rewrite it as a positive exponent by putting it down into the denominator. So looking at this example, x to the 4th over x to the 6th, well, using my rule of exponents that I saw, subtracting the exponents, this would be 4 minus 6, which would be negative 2, right? That's x to the negative 2. But using the, if I actually think about what's going on here without using a law of exponents, I get x times x times x times x times x. So I have 4 copies of the x up top and 6 down below. Yeah. Cancel them out. I end up with 2 down in the bottom. So x to the negative 2 is the same as 1 over x squared. Yeah, let's ignore that. Alright, so something like this. If we had let's just look to see what happens here. The 2 over 8, I would recommend thinking of this as several different fractions. So the 2 over 8, a common factor of 2 can cancel, and we're left with a 4 down in the bottom. And really, we're left with a 1 up top when I cancel out. I generally don't write the 1 up there unless there's nothing else up there, though, so I'm just going to hold off. M to the 6th over m cubed is m cubed. 6 minus 3 is 3. N squared over n cubed is, 2 minus 3 is negative 1. This would be n to the negative 1. However, what I could do, instead of writing it as n to the negative 1, I could write it as m cubed, 4 down there. I could move it down there with the n on the bottom, and you can see in this way I can avoid having a negative exponent. In general, when we're talking about simplifying some of these things, you'll get instructions so that instructions that say all of your exponents should be positive integers. Negative 1 is not a positive integer. So this would not be a good a final ending point, because your exponent is not a positive integer. However, if you move it down into the denominator, that one is a positive integer, so you'd be good there. All right. Let's do another one of these. We're taking 8 divided by negative 2. You can throw a negative in there. It doesn't matter if it's on the top or the bottom, except it's a little bit weird to have a negative on the bottom, so I'm going to move it up to the top. Canceling a common factor of 2 leaves a 4 up top. And when we have x squared over x cubed, you could call this x to the negative 1. And actually, I guess I didn't really need to write the division bar in there, because there is nothing in the denominator of this. We get negative 4x to the negative 1. And I'm going to take one additional step and move that x to the negative 1 down into the denominator and call it x to the positive 1, using my property here. Alright, on this one, 5 over 15 leaves a 3 down below because there's a common factor of 5 that I can cancel out. X to the 4th over x, 4 minus 1 is 3. And y squared over y to the 7th, 2 minus 7 is negative 5. You might have noticed by now that there actually is a little bit of a shortcut I could have done. If I'd done 7 minus 2, I would have ended up with the y to the 5 there on the bottom. I don't know that I'd recommend using shortcuts like that too incredibly much, because you do need to know this whole negative exponent thing anyway. I don't really find it's worth your time to learn extra stuff for shortcuts that only sometimes work. If we have something like this, where we have addition and subtraction on the top part of the fraction, our only recourse is to split this up as several different fractions. 12x to the 6th over 3x squared minus 9x cubed over 3x squared plus 6x over 3x squared. This is very much like what happened in one of the previous videos, but it's a little bit different. Let's see. This first fraction, I can cancel a common factor of 4, leaving of 3, leaving a 4 up top. And x to the 6th over x squared is x to the 4th. Here I get a 3x. 9 over 3 is 3. 3 minus 2 is 1, so this is x to the 1. And this one, I get 2x to the negative 1. That x to the negative 1 is a little bit of a problem, so what I'd want to do is I'd want to put that into the denominator. But the question is, the denominator of what? Well, it's only the denominator of that term. It's not taking the entire thing divided by x, it's only taking the 2 divided by x. Because normally this would be, if this was 2x squared, this would not be multiplying everything else by the x squared, this would only be taking the 2 times the x squared. So in this case, this would be 2 times the x to the negative 1. It's just 2 divided by the x there. So that would be my answer for that one.